Hello, my name is Andrew Bautz. Today is October 11th, 2023, and today I'm talking about a Stirling engine and how it relates to Newton's third law. So, it's supposed to be put on top of a hot cup of water, and it spins the wheel on its own. But how? Well, the hot air from the water comes up to this little black piston here, moves it up, and then when it hits the top here, it releases into the air and transforms into cold air, and it wants to go down. So the heat gets turned into colder air, and it pushes the piston down, and it keeps on going in a loop like that.
So you're getting warm or hot air from the bottom, pushing the piston up, and then the heat coming off of this apparatus
it cools down.
Cools as it rises away from the heat source. So let's put it on.
It takes a little while.
Takes a little while. All right, fair enough. So we'll just sort of wait for it to do its thing, and then
the hot air likes to rise under it from the hot glass of water, cup of water. And it pushes the black hockey puck looking thing up because the hot air wants to rise.
So the hot air rises, and it pushes the piston up,
and then the hot air gets pushed out of the container thing here into the air and cools down. It's relatively colder out of here than it is in here.
Cooler out here. All right, so you're going to kickstart it there with a little push, and
goes on its own. The hot air is making it rise, and the cold air that's from outside of the little capsule pushes it down. And it does get some major speed.
It really is. Let's watch it for a while. Can you explain to the viewers what happened earlier when we just tried to kickstart this thing without a heat source under it?
It stopped spinning because there was no heat source to keep on pushing the piston up.
Okay.
And the way this relates to Newton's third law is this piston being moved up moves this little thing here connected to a wheel that spins this. It moves up and down.
So what is the motion of the piston actually doing? The motion is doing what? It's pushing air
up. It's pushing it up and then pushing it down. The piston is being moved up and down.
So what is
it pushes, and this little hockey puck looking thing pushes up on this little connector that connects to this wheel-like thing that connects to this wheel here.
What is Newton's third law?
Every action has a reaction.
Okay.
This thing moving up moves this thing up, which in turn spins this wheel.
Got it.
The reaction of this little hockey puck moving up moves this in a spinning direction.
Thank you.
There's also a little piston here just doing its own little thing.
So that's directly related to the air that you were saying was getting displaced. This little sort of cylindrical cylinder inside a cylinder. It's really going now.
Yeah. It will stay at this speed for a while because it's not going to get any warmer. It's just going to get colder. The air's going to get colder, not warmer. It's going to start to slow down eventually.
Would this work if the temperature of the air outside on the top of this device was the same as the air that's being displaced by this piston down here?
No, it would not work.
Why not?
Because there's no difference to displace the piston. It'll just stay still.
So there's no difference in air temperature below and above in that scenario.
But a fun fact about this is
okay,
it can do this if it's a cold cup. Because the cold does the reverse of what the warm air does. It does the reverse of what the warm air does and moves the wheel in the opposite direction.
So you're saying if the water in the cup was extremely cold and the outside temperature was quite warm, you'd have the difference you'd need in temperature.
Yeah, and it would spin the other way.
It would go the other way. Thank you. I think what we'll do is keep track of how long this thing actually runs on this cup of water, and we'll put it in the description section of the video. Thank you.